Okay? When you have these two lines here, they mean it's an isosceles triangle, means they're the same length. By that logic, this angle here and this angle here are the same. All three of them have to add up to 180. Therefore, there's 110 up for grabs, because there's these two here, the two x's have to add up to 110. Divide that 110 by 2, and you get that this one here is 55 and this one here is 55. Okay, keep looking. Next one you realise is a straight angle. Straight angles have to add up to 180. This makes this one 125. This one here, all three sides are the same. 60, 60, 60, because it's the equilateral triangle, makes the outside one 120. Okay, next thing you need to know is what's called alternate angles and corresponding angles. Corresponding angles I saw remember by using the letter F, just with a slightly elongated part of the F. Basically what this means is that this side here is the same, these angles are the same, because this line here is parallel to this line here. Everybody happy with that? Yes. Second thing you have to know is opposite angles. Opposite angles basically means that when you have two lines that don't change direction and they go straight through a junction, that one's the same as that one is the same as that one. Finally, we have the third letter, which I remember, FXZ, or ZXF is what I usually remember, right? So this one's a Z, with a Z or an N, or it doesn't matter if it's backwards or upside down, really doesn't matter. Provided that the two lines you draw are parallel, what happens is this angle in here equals this angle here equals that one there. Everybody happy with those? Yeah. You're to know them like the back of your hand, okay? Now, once we've cleared that up, what we have is question 3 and 4 here. And with 3 and 4, what we're going to notice is we have to figure out what each one is. Okay, so I'm really going to have to, actually really going to enlarge this, because I need more room. Now, this is a 50. Anybody want to tell me what that's a 50? Opposite. That's a 130. Anybody want to tell me that's a 130? Straight angle, okay. This one here? Anybody? 65. And then add the two of them together. 115. Take 115 away from 180. That's a 65. Okay. Now, let's look for any corresponding angles. See the Y? Does the Y have anything corresponding with it? The 65 down here, right? So if you will, I'll just keep doing this here. I'm looking at this part here. See the way it's like a backwards F? Turn around, so that makes that 65. Okay, everybody seems to be happy enough with that. Now, next one that I have here. Any takers on what each one is? No idea. Let's make this one. This one's going to be 50. Corresponding angle, this one to 140. Makes that 90. Because 50 plus 40 plus 90 is 180. Makes this one 90.
Oh yeah.
Oh, sorry. That's a 40, by the way. Sorry, that one there was a poorly written 40. That's 140. 40. It looked like a 90. That's a 50. 50 plus 40 is 90. 90 plus another 90 gives you 180. Sorry, I say it was poorly written for. Okay. Next one, number 6. Okay. You're looking at it and going, alright. There's a rule. Anybody tell me a rule about parallelograms? Any parallelogram.
Add up to 180.
Opposite angles add up to 180. Okay, so that's what you need to be. You need to have rehearsed. Okay. So here we go. Okay, this one here. Okay. Not so much opposite. The two sides. The two blues add up to 180, and the two reds add up to 180. It doesn't make sense for these two here to add up to 180. Why? Because they're both obtuse. So that the two top ones can add to 180 as well. Yeah. The two sides are the two tops. Okay. Now, Now that we've established that, okay, what we're going to do is look at this, and the first thing I'm going to do is I know that this one here is parallel to this one here. Are we happy with that?
Yeah.
Then I have a Z. So what does that mean about this angle down here? 45. Okay. Now, what else can we determine from that?
6 degrees and so forth.
Sorry?
6 degrees and so forth, straight line.
Yeah, straight line. Right, what's it called? Straight angle. Which makes this one 50.
You know, or PS now as well.
And now we can find this one here, which is 85. Because that has to be 85, doesn't it? Because it has to add up to 180.
Yeah.
And therefore this one here is going to be alternate to the one I just found a second ago. I'll show you how. This one here. Alternate angle. So will that make that one? 85 as well. And look guys, just pick your answer there, you know what I'm saying? Like if I'm looking for PQR, P to Q to R is 50. If I'm looking for PRQ, P to R to Q, 85. Q to P to R, 45. Justify our answer. You got it's what I spoke. Remember I said alternate, corresponding, straight angle. These are the words you have to use when you're talking about your answer, okay? Okay, I'm alright for a minute. This one here. Okay, I found this one tough enough. CAB is 135. So angle CAB is 135. Angle EDB 147. Calculate ABD. Okay. So ABD is the goal of the question. So there we go. The whole goal is to find out what this one here is. Okay. So let me see what I did here last time. It's probably in my book actually. It's the first one I did. Okay. So what I'm going to do is this one. I'm going to construct something like this. Okay, and then I figured out that that was 90 and that one there is 90. I then figured out that this is 135, isn't it? Mm-hmm. So that makes that one there, that'll be 45 in there, yeah, and then the other one will be 57 in there, won't it? Yeah. So you just have to zone in on this triangle here, ABD. That's 45, that's 57, therefore the other angle will have to be, anybody? 180 minus 45 minus 57, which will get us, anybody know? Let's go for 78. Yeah. Okay, that's 78. Okay. Next question then. Yeah, these are really easy. I'll do one of these for you, okay? Lads, part 2. Do you remember this rule? Theorem, is it theorem 11? Theorem 11. This one here, they divide each other in the same, because these are equally spaced. Where does it say that in the question? Equal intercepts on the transversals, so that means they're equally spaced. Because they're equally spaced, what this means is this: 2a equals 8. A therefore equals 4. 3a therefore is 12. 12 has to equal 6b. B therefore equals 2. Quite easy. Okay. Number 10. The diagram shows 3 parallel lines L, M, N. They cut equal intercepts on the line U. The line V makes a 60-degree angle with the vertical as shown. If AC, which is this line here, is 16, find DE. Well, if that's 16, it means that one's 8 and that one's 8, which in turn means that's 8. Then if I zone in on this triangle here, what happens? 60 degrees, right angle. 8. I need to find out what DE is. Call it X. What function do we use, guys? Sine, cos, or tan? Anybody remember? SOHCAHTOA. Cos is the adjacent divided by the hypotenuse, okay?